Perfect. Then welcome everyone to AllCodeV's 229. Um, the first one after we have all of our main scoping decisions done, so this is nice. We can focus on other things now. We still have quite a packed agenda actually, so let's just dive in. First, some housekeeping. Specifically, there are not one or two, but three different breakout calls that will all start within the next 2 weeks that wanted to briefly announce that they're getting going. And the first one up is Antonio, who wanted to present the post-quantum transaction signature breakout call. Antonio, are you on the call?
Yep, I'm here. Thanks, Ansgar. I promise you I don't steal a lot of time. Pretty quick, so you probably seen the announcement from Justin last week about this new post-quantum acceleration from Ethereum and in general. And we have this post-quantum transaction signature breakout room starting next week. We kick off with at February the 4th, 3 o'clock. The agenda is already kind of ready. It's on the link. Everyone is welcome to join. I'm looking forward to starting this, and that's about it. Thanks a lot.
Perfect. Thank you, Antonio. The second breakout call to be announced is the L1 ZKVM breakout call. I think, Kev, if you're on the call, you wanted to briefly announce this?
Yeah, so we have the call on February the 11th at 3 p.m. UTC. It doesn't coincide with Antonio's call. I can post a link in the chat right now.
Sounds good. And then the third one, I think, Maria, you wanted to announce a breakout call specifically around the Glamsterdam repricings. Is that right?
Right. So we are kicking it off next week. So it will be a bi-weekly call on Wednesdays, 2 p.m. UTC. So the next one will be February 4th. So it's in the same slot as the block level access list, but 1 week off. And yeah, the focus will be just all implementation details and specifications for all the repricing ZIPs for Amsterdam.
Sounds good. And just because there were so many calls announced, just as a reminder, of course, these are all like specialist calls, so there's absolutely no need for everyone to feel the need to attend all of these. It's about if this touches something that you are directly involved with, then this is probably a call for you. Awesome. Um, then onto the next agenda item, which is a few different Amsterdam related topics, mostly around DevNets and DevNet planning. First, I think we have Stefan who wanted to give an update on DevNet 2. Is that right, Stefan?
Yeah, sure. I'll give an update. I'll share the latest DevNet 2 document in the chat. I updated some parts of the document. I'd like to highlight just some clarifications to EIPs. I added like a new emoji next to them. Specifically for 7708, there were some clarifications made during the development and also the changes to 7778, where the receipt field was removed. If clients could take a look that they are aware of all those changes, I summarized them in the document. And we came to a launch date for DevNet 2 on the 4th of February, so next week. So it would be great if all clients could be ready by then, and I trust that we will be able to. And I think clients have already made a lot of progress. And also another part on this for this document is client feature flags. There I added a section where clients can enable and disable optimizations. This is already filled out with Bezos feature flags, but it would be great if other clients could communicate the feature flags that they have so that we can benchmark BAL against not having BALs active in the DevNet and then later on in shadow forks as well. I think that's pretty much it.
Sounds good. Thank you for the update. Are there any comments, any other topics specifically related to DevNet 2, Val DevNet 2, that anyone wanted to bring up? Otherwise, then next up, and this is the next two items are related more to DevNets going forward, but also specifically this one also directly for DevNet 2, which is the a block level access list specific client optimization. So just as a reminder, block level access list, obviously there's the base spec compliance, but then on top of this, there's four distinct optimizations to actually make use of the new possibilities Balz enables. That's the parallel execution, the batch reading, parallel state route calculation, and the sync. And there was some desire to formalize to what extent these optimizations are basically expected as part of the glump scope, and their relative prioritization and so on. And first, I think Tony wanted to give a quick update on that side of things specifically.
Yeah, so from the BAL optimization side, things look quite good, I would say. So we now have GEF and BESO being ready, having all three, what I would call the more mandatory optimizations implemented, which is parallel execution, the batch reading, and the parallel post state route calculation. I think also Nethermind has all three optimizations ready, have to check in with them. So from that perspective, we are ready to test and benchmark the whole thing. And we should also be ready to then have the first shadow forks against mainnet or even bloatnet in order to test how much we get from the state locations in the bulk, because this is still an open item that we needed the optimizations for, and we are now ready to actually find that out.
Sounds good. And yeah, you mentioned the state locations, because yeah, that's one of the two sides of BALs. And my understanding was also that also from the repricing side, kind of these batch read optimizations are actually relatively important. Maria, I think you wanted to say a few things about this.
Yeah, so I just wanted to stress the importance of having a cohesive set of optimizations, and I think the batch reads are an important one because for instance, for parallel execution, it's kind of easy to reason about what sort of um, gains in terms of runtime we'll get, but for the batch reads is still a big unknown. And so for us to take that into consideration when we are doing the repricings, we really need to have the optimizations in place so then we can benchmark them. And in terms of timeline, in order for us to have enough time to benchmark and test everything ahead of interop events in April, I would say we need to have the core optimizations done by the end of February, so that we can start then benchmarking the operations we are repricing.
Right. And so basically, in a way, to synthesize this, both of Tony's and Maria's comments is I think the proposal would basically be that we formalize the expectation that not just the BAO-based spec compliance, but also these individual optimizations basically are part of the official fork readiness expectation. With the nuance that I think the fourth one, which is the sync, I think is more up to the clients. If you have the feeling that you need this in order to have efficient sync and under higher throughput levels after the fork, then that's more up to the individual client. But the other three optimizations would basically be part of the official fork scope, and with the specific ask to prioritize the batch read one first in that process. So the question would be, is that okay with clients, or is there any objections? Maybe one of the optimizations that any client doesn't feel comfortable with being able to support in time for the fork, or can we basically make that decision? Andrew?
Sorry, I have probably a stupid question. What is this sync optimization?
Yeah, that one maybe I'm a little just too imprecise. So that's just primarily for just for I mean, I guess sorry, Tony, maybe you can give more precise context.
Yeah. The sync optimization was basically using the block level access lists for the healing phase in SnapSync. So this might not even apply to all of the clients, but it does for Geth, for example. And so it's one of those optimizations that you can use, but you don't need to use because it's not something in the critical execution path.
Right, I see. Thank you. Yeah, okay. So in Aragon, we've been working on parallel execution and like started to think about parallel state root calculation, but I don't think we have anything in the works in terms of batch reads. So basically, you are saying that we should prioritize batch reads.
I mean, we needed it at least for a few clients because what is currently very important is finding out if we even need the state locations in the block level access list. And for that, we need at least some data points of at least a few clients to determine is it important or not. In the end, when it comes to the fork, I would assume that we don't even need to explicitly say which optimizations need to be implemented, but we can more like implicitly set the gas limit to a certain point where, yeah, clients that we use for benchmarking are basically fine with it. And I assume we will just use all clients for benchmarking. So in the end, all clients, I assume clients will just have all the optimizations implemented.
Understood. Thank you.
No, sorry, Tony. I think it's important to clarify something. So I don't think that's true for the repricing side. So if we need to understand how much state access, so reads and writes, perform in comparison to compute operations, in order for us to price them correctly. So if we don't assume any optimizations, then we'll be pricing state reads and writes much more expensive in relation to compute. And so then they will be a bottleneck, right? Like we could increase the block limit, but for those operations in specific, the throughput is much lower. So that's why it's important by end of February to have a base set of optimizations that we all agree will go in so that then we can do the repricings, taking those into consideration, because otherwise we'll be performing in a lower throughput than we could.
Yeah, we're saying the same. So I was referring to the baseline being all optimizations implemented and not none of them. So we just use Geth and Beso for now because we know they have all the optimizations implemented already. So we don't even need to wait until end of month because I think, at least from Beso's side, what I heard is that they are more than ready with their batch IO implementation. For Geth, we can double check with Jared if they are ready too, but it looks like we have the optimizations ready for the benchmarking.
Okay, but then we need to agree that by the fork, all clients have those optimizations in place, because otherwise we'll be creating bottlenecks on those clients, right?
Yeah, I mean, those clients will not be able to keep up with the chain, basically. If we go to a gas limit where all optimized clients are fine with it, then a client that hasn't optimized won't just be able to keep up, I assume. So this is like an implicit assumption here.
It's still
Right, and then
right?
can we just to bring it back into the full group? So Saba, you wanted to say something?
Yeah, I was saying it's still hardware and resource dependent. So it's not that the client cannot keep up. It might need higher resources. So
Right, yeah.
Yeah.
I think we
maybe
can assume that all optimizations are ready by the fork. I think that's a fair assumption.
Yes, I want to double check with Andrew from the Aragon point of view. Do you feel comfortable, at least for now, moving forward with the understanding that by the fork all optimizations should be ready, and then during the process, of course, we can always revisit the scope of the fork and possibly downscope. But is that at least is a reasonable target?
Yeah, sounds good.
Okay, then I would say for now we just basically we clarify the three main optimizations are basically expected to be part of the fork scope. We can revisit this if further closer to the fork. Not all the clients are ready, but for now this is the expected kind of scope. And then the sync optimization for those clients where that actually even is relevant for their specific approach to sync is up to the individual client. Just do make sure that you kind of in general thinking about that question because as the chain moves faster, of course, sync is a bit more challenging. Jared?
Yeah, I just wanted to clarify something. So whether or not individual clients make use of BALs for the sync, I think there is still the requirement that they are served over dev P2P up until the weak subjectivity point. So um I mean, that's still the case here, right? Like when we're saying
Yeah.
that this, yeah, okay.
Yeah, just to clarify. So basically, exactly. Like the idea is, I would say there's the general BAL spec compliance, and now of course syncing is that the P2P side is a bit out of the specs, but either way, like there the expected behavior is you are able to serve them. And that's not optional. There you have to follow that behavior. And then the question is just for performance optimization specifically. And on that specific performance optimization point, whether you actually end up using BALs for any part of your sync, that is up to you. And you like clients just have to investigate, yeah, to what extent that's necessary and possible for them. Justin?
Yeah. Oh, okay, you can hear me. Um, I was just asked to weigh in from an implementer's perspective for presenting signing requests to users in terms of the dynamic pricing from 8037. And I just wanted to weigh in and say that on that side, it's very
What
straightforward. Oh, sorry.
can we just wait with this until we get to 8037? Because
Oh,
I think it's a
apologies.
good point. But yeah, but we're not quite at the agenda point yet. But
Okay, I
I'll
wasn't
call on
sure.
you. Yeah.
Oh, apologies. I wasn't sure where to interject with that. Thanks.
Yeah, no, it's yeah, there's no explicit agenda point, but this is ideal, so I'll call on you in a second. Awesome. But yeah, so then the BAL specific kind of questions I think are for now locked in. And then yes, the next agenda point is specifically the just briefly revisiting the question of CFI EAP priorities for future DevNets. Um, and that is directly related to what we just talked about with BALs. So specifically on ACDT, there was a discussion about how to scope future DevNets, and the idea or the general consensus there was that it makes sense just for keeping friction minimal to make DevNet decisions to continue making those on ACDT. But ideally to have a bit more of a structured input from the ACDE side to give guidance to which ERPs to prioritize. For the future, we're now like preparing some sort of um, EIP kind of DevNet priorities ranking that we can discuss, say, on next ACDE in 2 weeks. But just in the meantime, I just wanted to briefly on this point mention that um, it at least from talking to people, it sounds like actually we would, from the ACDE side, recommend that specifically the BAL optimizations are maybe prioritized over adding future EIPs into, say, a DevNet 3. And so that like extra EIPs should only be considered after those optimizations. And that possibly specifically EIP 8037 looked like, if anything, kind of a stretch goal for next inclusion in an upcoming DevNet. Of course, that's not necessarily consensus take. I just wanted to put this out there if this generally sounds reasonable to people um, as a rough prioritization to have in mind as we are going into future DevNets, DevNet 3 at some point. So does that generally sound reasonable? Basically, like prioritizing um, BAL optimizations and then EIP 8037, the state growth one, before any further EAP inclusions into future DevNets?
I think generally prioritization is very hard, and I think we're making pretty good progress on block level access lists, and I'm not too worried about them at the moment. But in general, yeah, we should have a clear process that we follow for ACD in ACDT for the DevNets.
Yeah, that makes sense. Daniel?
Yeah, I would say if we want to do benchmarks, we should at least consider the smart contract size increase for the next DevNet, because this could change things. So maybe not 8037, but the smart contract size increase to test the new worst case.
Okay, yeah, that's actually a really reasonable point. And then I think, yeah, what best just to not keep this agenda point also somewhat concise. Obviously, any decision on the next DevNet scope will be done on ACDT anyway. But then, yeah, like this is a good prompt to look into the contract size related performance questions and whether that should motivate fast tracking that EIP for future DevNets. Sounds good. But yeah, then I think we can keep it short here on ACDE. Tony?
Yeah, maybe a bit related to that. There was also this discussion if we should go to a higher gas limit for DevNet 2. And yeah, I guess we don't need to decide about this today, but it would be great if clients can quickly check if everything would be fine if we go to, for example, to 150 million gas limit for DevNet 2. This would help us to test things even better, but of course we don't want to run into any weird limits, for example, the 10 megabyte RLP limit and stuff. So just to double check.
Sounds good. And that again, that would not be a decision for today. It's just a prompt for people to look into this so that decisions can be made in the future. That sounds reasonable. Yeah, and then going forward, we will find a way to formalize the question of DevNet scoping process between ACDE and well, ACDC and E and ACDT. But for now, I think that's a good place. Then I think now would be a good time to briefly interject. We just mentioned 8037 anyway. Justin, if you wanted to briefly talk about this.
Thank you. Yeah, sorry about jumping in. I didn't really see quite where I was supposed to go with the agenda. Yeah, basically in terms of the implementation side and how we present this to users, we're still showing the same single gas field. So there's not really too much to do. I think one UX consideration that could be nice is that if we can surface why the pricing is higher when there's state-heavy transactions. But outside of that, it's very simple. It's going to basically flow through to most wallets, hardware, and software. My only consideration there for users is being able to meet their expectations if they're using some sort of gas price estimating tool, and they might not see that their particular transaction may not align with something that is presenting an estimation for a simple transfer. But
Makes
otherwise,
sense.
easy. Yep.
Yeah, and just for for going forward, I think there will be several more of these questions around the impact of repricings on existing flows, tooling, all these things. Um, Maybe Maria, you are going to have these repricing breakout calls. Would that be a good place to also talk about these potential compatibility issues, or is this more an ACDT topic? Where to point people that have questions around these topics?
Yeah, I think the breakout calls would be a good place for that.
Sounds good. Awesome. Thank you, Justin, then. And just to flag, by the way, because we just talked about the BAL optimizations, there's this discussion right now in chat around if we want to actually have at least the three of the four optimizations officially part of the fork scope, is there any way in which we want to express that in documentation? Yeah, I don't think we need to discuss this today. I mean, the conversation chat makes a lot of sense, but I do think it's actually a really good prompt, and so I'll also like look into this and from the process side and see if there's a need and a good way to make that a bit more legible process-wise. Awesome. Then I think we can move to the next agenda item, which is, well, actually, there's more Glumpstum scoping to be done. Although, I mean, when we done with that, yes, kind of, but there was three EIPs still that are not protocol changing that we basically postponed decisions on because it's just not as important as the protocol changing ones. But now is the time that we should also make decision on those. And these they are all listed in the agenda. The first one is EIP 7610, revert creation in case of non-empty storage. I think this one was a bit of a confusing one because it wasn't quite clear whether this is already the way the protocol works today or not. So whether this is actually a protocol change or not, whether this needs to even be part of the hard fork or not. I'm not super in the loop on this. Do we have anyone on the call that has looked into 7610 and can give some context?
I can give some context. So basically, we have already decided, or we had decided this for the last hard fork that we're going to take. We're going to do this because, or we're going to specify this, and it was already included in the last hard fork, if I remember correctly, but we never. Yeah, and then around the fork proposal times. This was discussed again, and mainly from the RETH team, because it requires them to do another disk lookup, but for us, it allows us to do certain optimizations with the database. So it's basically like, yeah, it is a clarification what would happen in a case that cannot really happen. And yeah, maybe Dragan can also speak on this.
Yeah, before we go to Dragan, just briefly, Marius, then from your side, does that mean that for you there would be value in having this be part of the official fork scope this time around?
I would say so, yeah, because then we wouldn't have to have this conversation again.
Okay, makes sense. Dragan?
I will continue where Mario stopped. Basically, this specifies unrealistic scenario. Basically, you would need quantum computing to break this. So adding additional checks and fetches for database for something that's not possible to trigger on the current mainnet or not possible to trigger in at least next 10 years, I think it's not something that would want to add. That's the main point here.
Makes sense. So I just from my understanding, so basically there is, for historical reasons, there's 28 contracts that exist in that state today already. Is this I'm not quite sure I understand, but like for the future to create more such situations, you would have to basically cause a hash collision or a yeah, is this I don't know, sorry, I'm
Yeah.
probably a little out of the loop on this, but
This related to the accounts that were created before the state clear IP, like 5-7 years ago. I'm not sure exactly. Basic accounts that has zero nonce, no code, and have some storage. So this is the AIP specifies how if somebody wants to recreate that particular address, new account, new contract, what would happen? And this is not possible to happen without quantum computers, basically.
And in terms of performance, so it's one thing to just special case these 28, right? That would be easy in terms of performance, but then for future places where this could happen, you would always have to check that anytime you actually deploy a contract that the storage route is basically the empty storage route, right? So you basically have to load the storage route, and otherwise you would not have to load the storage route. Is that the difference in terms of performance?
A simpler solution would be just to remove those accounts. Basically, just use hard fork to remove those accounts. Idea when this AIP was proposed was, hey, we will have Oracle trees in the future, and with transition with a new tree, we could remove accounts that basically have this case. Oracle tree was basically delayed, let's say it like that. So this is not the case. Either way, if the quantum computers come, we'll have a lot bigger problems than this. This would be like simple solution to remove just all accounts.
Right. I think Vitalik in chat is saying that maybe it's not actually quantum, but it's because it would be a hash collision, right? So like you actually that's more classical compute that you'd have to brute force throughout the problem. Either way, but yeah, so I guess the question then still is, do we so then it sounds like this is not just a nominal ERP, but actually it does mean that you have to have the logic in the client that goes and looks at the storage route, right? So the question is whether to include this or not. Guillaume, you had your hand up for a while?
Yeah, so sorry, I'm in the street, so I hope the sound is good. If you end up with a unified tree, vertical or not, binary, whatever, the storage route makes no sense. Like it's not a concept that will exist anymore. So you will not be able to enforce this. So yeah, this thing can only happen if you have a hash collision, but that's not a tree problem. That's a address scheme problem. And if you like, there will be a moment, or there might be a moment where this will not be enforceable anyway because the state root no longer exists. So in my view, we should not include it because there's no way to make it work in the future.
Yeah, I was, I just wanted to follow on because I made that comment that like I intuitively dislike anything that moves the sort of API of storage away from just having a get operator and a set operator and nothing else. One example of like a weird exceptional case I can come up with is let's say someone does have 2 to the 80 compute, and so they are able to create a collision. And then they basically create a contract, and then inside of that contract, they set some slots, and then possibly, like inside of that creation, it does a re-enter thing, and then it tries to create it again. And like basically, not only do you have to look at the root, but also potentially the caching logic inside of a client would have to have an is-empty operator, and so like the number of special cases potentially blows up quite a bit.
Right. That makes sense. Dano?
So I think a couple of things we also need to point out is that this was integrated into last April into the uReference test that all clients pass. And every other client did change code to make it work. So everyone else has this implemented and working as is. So if we were to pull this out, then 4 clients would have to go and change code to pass tests again.
I see. Well, Vitalik, you unmuted?
Yeah, I guess I was thinking of like what is there a kind of nicer, cleaner solution that takes into account like basically doesn't involve needing an is-empty operator, and that makes is future-proof even against address collisions. And the best thing that I can come up with is like somehow as soon as a creation operation begins, you create the account object, and then if the account object gets created, then like no other create can happen, and that's irreversible. So that's kind of, but I mean, I guess like if we implement this now, we can always go switch to something like that in the future and like stick it in as part of a binary tree or something else as well.
Right. That makes sense. Daniel, do you still have your hand on up or up again? Okay. Yeah, so then to me it seems like basically this is for now more a theoretical scenario that in the very long run could become not theoretical. But as of today, basically client behavior diverges. So if this were to, for some magical reason happen on mainnet, clients would behave differently, which is of course not great. So I do understand the desire to standardize this behavior completely. It does seem not trivial how to do it though. I mean, I understand the short-term temptation to just do what the majority of clients already does, but then I also understand the concerns around kind of principle forward compatibility. What is the best way for here to make progress? Do we have we can of course also just say we don't standardize for another hard fork and just expect nothing bad will happen, or we can take some more time to look into how to standardize this behavior. Um, let's put it this way. So my understanding is Reth is the only client that currently does not follow what the other clients do. Is this right? Just to confirm.
I verified this with the existing execution spec tests. Yes.
I see. I do think, I mean, yeah, from Dragan, maybe how acceptable would it be for you all to, on the Reth side, to specifically just say, just for simplicity, to for now have standardized client behavior to go with what the other clients are already doing, make this the official formal behavior, and then revisit and find a more proper kind of long-term solution for this at a later time? Or is this, would you be strongly opposed to this because of the extra effort on the Reth side?
I don't think it's even not about effort. It's like implementing something that we know that's not going to happen. We were fine a year ago to just skip those tests and not execute them. I think we are probably going to continue doing that. I need to talk with team if they want to do that, because passing all 100% tests, maybe they want it or not. But in general, this becomes, yeah, even like we are secure not passing those tests.
Makes sense. Yeah, but in terms of just the EAP, for the EAP process, I feel uncomfortable including an EAP. I understand even if it's a theoretical EAP, but like as long as we already know not all clients will be compliant, I think to me, including the EAP, even if it's more symbolic act, still would be this. We all agree that this is now canonical behavior, which I think we should only do if it's actually canonical behavior by everyone. So as long as from the rest side there's still an objection, then I feel like for now we can't include the EAP in the fork. But then I will for now just keep it in CFI. Again, even if it just stays in CFI all the way until the fork and we just don't have it in the fork, that's fine. But I'll keep it in CFI for now just to indicate that there's still an open issue to be resolved. Yeah. But then from now on, I think the idea is to try to resolve this asynchronously and not on future ACDE time. Okay. Then this one was the most like theoretically kind of complex one, just because of this weird space it's in. The other two should be a bit more straightforward. So the other two, the next EIP here is EIP 7872, Max Blob Flag for local builders. So this is, I think, something that in principle everyone agrees is a useful thing. The question is just, is this something? It's obviously not a protocol change. Is this something that would be worth including in the official hard fork meta EIP to indicate that we expect all clients to support this by the time of the fork, or should this stay out of the fork meta EIP? Do people have opinions on that EIP in particular and whether to include it in the hard fork meta or not? Felix?
So I have the opinion that the client flags should not be specified in the EIPs. It's useful to agree on the flags, and there's nothing wrong with the flag, but just putting it in, like, it doesn't make any sense for me. The EIPs are for the protocol, they are not for the command line interface of the clients. It's like a different thing.
Sounds good. I'm also seeing a few thumbs up from different clients on Zoom. So then I guess the default would be to just not have it be part of the meta EIP. Is there anyone who's strongly opposed? Anyone who wants to make an argument that this should be part of the meta scope? I mean, I guess not, but Felix, you want to say something?
No, I put my hand up again. I actually think we should DFI it.
Yeah, no, that's the idea. I'm just basically saying, is there, like, of course, we would make a decision today. So the question is there anyone who's like strongly opposed to DFI and would want to make an argument for CFIing it? Okay, then yes, let's DFI the CIP. So 7872 is DFI'd, but that does not mean that we don't want to support that behavior. It's just in terms of it's not going to be part of the fork meta EIP because it's out of scope for what a fork meta EIP should cover. Okay, DFI. And then the last one is the EIP 7949, which is the Genesis file format. Same situation there, I think, if I understand correctly. Basically, question is just, is this something that should be specified as part of the fork meta or not? Question here again is, do people feel similarly that this might also be out of scope, or do people think that this one might be useful to have as part of in scope for the fork? Justin?
Yeah, hi, I'm one of the authors. I think it's reasonable to say that it's not in scope. One thing I do want to point out, though, is that we have no standardization for chain genesis right now. And we do have standardization for things that kind of depend on chain genesis, right? So like BPOs, the ETH config specs that we're trying to put together. So it's a weird kind of gap that we run into here. I think in the future, we want to add more configuration richness, like per milestone EIP enables, and we don't really have a spec to do that. So, it's just a simple point. It's, not a sexy feature, doesn't need any coordination, et cetera, et cetera. It's just a little bit of tech debt, and it has a little bit of an impact on other features. So, thank you.
Right, and just to clarify, of course, we could also decide to standardize around this EIP without having it be part of the Glamsada meta EIP, right? These two decisions are in a sense orthogonal.
100%.
Yeah. Felix?
Yeah, from my perspective, I don't think there's any problem with us, for example, creating the spec inside of the execution specs repository, as long as we can agree among the clients that this is something which we all want to be bound to. So I don't know if this is weird or not, but there's basically, I mean, yeah, when it comes to changing the protocol, the implications are very wide. But when it just comes to changing things like the client configuration, we can also just make like a note in the specs repository that this is the format that we all want to use. And it doesn't have to concern the whole governance process. But we can still have specs that we all follow. It's the same with the P2P specs in some ways. Like we maintain the P2P specs outside of execution specs. It's kind of a question if they should move there at some point. But it's like we publish EIPs that say, yeah, we want to make these changes to the P2P protocol, but they are often treated outside of the hard fork process. But I mean, in the end, it's just like something that we agree with each other. It's not something that concerns the wider Ethereum community.
Right. So then what I'm hearing is basically similarly that we would maybe lean towards deifying it for the hard fork specifically, but still would then go ahead with clients standardizing, or at least considering standardizing around the behavior as specified in the EIP. Does this sound reasonable for people?
Yes, I think Nevermind is the only one that doesn't support the requested layout. I think Alexei FLCL is currently have a PR for that. I need to check it out. So we will get there because I think this is very important for DevOps standardize.
Sounds good. So then for the fork, Meta ERP, we make the DFI decision, but it sounds like people will still work towards having unified client support around the standard. Makes sense. So, but in terms of the fork, DFI on this one as well then. Awesome. So that was all on the kind of scoping, non-protocol ERP scoping side. We have two last sections. One is a quick presentation by Chaba on two more of these non-protocol change EAPs on the networking side, and then afterwards we will go into H-star headliners. Chaba?
Yeah, let me just share screen. Okay, yeah. So two of those things. So we are having different changes in mempool and blob pool, and they are kind of related, obviously. And some of them are touching only blob pool, some of them are more mempool. So I was putting here in perspective the EIP 8070. Everyone knows there's a sparse blob pool, and I'm having two other here. One is the EIP 8077, which is about the announcement that we have in the mempool. It's about the information, adding more metadata to that, so that then we can do things better, more intelligent fetching choices, especially as we are scaling now the mempool, scaling now the execution, and the scaling the mempool. The other one is specific to LBF, so replaced by fee. So we have a huge inefficiency when we are doing that for blobs in the way we are doing it now, and it's about that. So the basic idea is to not redistribute the blob content when we are just replacing and changing just the fee parameters. I have a little bit more detail. So this is the 8077. So the issue that it's trying to address is that when you have a node which is in the mempool, it's kind of living in this cloud of transaction hashes, and everything is fine until you can understand what are those. So you can actually get those transactions, and then you have the nonce, the source, the fees, and then you can do something with it. But if you only have the hashes, you don't have nothing basically. So this leads to many issues. If you are in a regime where you have nonce gaps, for example, you cannot fill those because you can only randomly try hashes and then hope to get the to fill the gaps. It's also preventing selectively fetching based on source address, or selectively fetching based on fee priority. So the proposal here is to make the announcements having more metadata. So two variants there. One is just adding the source and the nonce. That already allows to manage better the gaps and have the source-based filtering and other things. There is the variant where we are adding also fee information to this, and then you can do your prioritization and be selective based on that. A little protocol change in the sense of the semantics, but you can build intelligence on top of that, and that's the main thing. The other one is the 8094. So there the problem that is targeted is that when you are replacing a blob transaction, you are basically asking network to resend the whole transaction, and you don't have any way to not do it with the current protocol. So the proposal is to change the protocol so that if only the price is changing, then we can actually send this information. Then you can realize that the actual blob sidecar content is the same, and then you don't download the sidecar content. I'm not going into the protocol details, but these are the two topics basically. The first one seems easier. The second one is more intertwined with the sparse block pool and related ideas. So I'm focusing on the first one. Started adding some measurements on kind of how many times these things are happening. Left is the related to the later presented EIP. The right side is to the 8077. Also, kind of started measuring how much would be the effect and starting to implement it. So what you see here is that we already have quite an amount of announcement traffic, like 30% of the traffic is announcement. But we know we have easy ways to reduce that because we are announcing to everyone, and that's a lot. So if here we're adding more data to the announcements, maybe doubling the size of the announcements or maybe tripling the size, but we also know how to reduce that because we don't have to send these announcements to everyone from everywhere, basically. So we can mitigate that effect and have this intelligence in the mempool. That's it, basically, to stay quick.
If I can take some comments on 8077. So I was a few years ago, like 2 or 3 years ago, when we were doing like a big overhaul of our transaction pool and with some other stuff, I was wondering, I was thinking if to propose exactly this, to add nonces and senders to the announcements. We decided, even maybe more time ago, we decided not to and build our transaction pool to support nonce gaps. So basically, we can take nonce gaps, but we will drop them relatively quickly if anything other has pressure on the pool. And my logic was that we should potentially because we would have to announce not only that to make it actually complete, but also things like max fee per gas, blah blah blah, all those gas prices, everything, because all of this actually makes is needed for decision to something to keep in the pool or not to keep in the pool, and to download something or not to download something. So basically would have to announce almost everything except transaction data, of course, and blobs. So that was my conclusion, that to actually make this complete, to make this really useful and complete, we have to kind of have almost all of the transaction fields into that. So that's why I kind of decided against it, not to complicate the protocol here. So I'm fine with that, but again, like if your base fee is too low or other fees, you still will get transaction announcements. You will download those transactions, and then you will decide, oh, they are actually worse than what I have in the pool. So this traffic you can consider it wasted at the moment. So I don't really think that this is that crucial.
So that's why I have the fees in optional, because I have these doubts about that, because there's quite some metadata there. But even the source and the nonce in itself is allowing you to do useful things. So the gaps, we also support gaps. The problem is that you cannot fill the gaps. The gap filling is really based on the assumption that you have the capacity to download everything, and that will not be true in the future if we really are serious about scaling. Not to mention, nodes are heterogeneous, so not everyone can download everything. And the failure modes in that sense are not good. And then there is the advantage of having the source. I'm also less convinced about the fees. I see the advantages, but there is the implementation factor of, there is the factor of having more metadata there. Fees. We can do things. We can quantize the fees, for example, so to compress it. So there are options to compress. There are options to not have all the announcements like this, only a portion of them. So we can work on the the bandwidth part of that relatively easily. Yeah, but we can work on working out details differently. Yeah, I don't. I have and Ansgar if you're calling on people.
Yeah, I mean, either way. Yeah, Fabio.
Yeah, I want to say that the other IP, the replaced by fee for blobs, seems more relevant to reduce the bandwidth. About this one, I'm talking for Bezo, of course. Also in Bezo, we don't have any more issue with nonce gaps since the new layer transaction pool released 3 years ago. And I'm not sure about other client if all clients are now fine or not with nonce gap. So because adding all those fields actually could means that for simple transaction we are basically doubling the bandwidth, because if the transaction hasn't a payload, you basically announce it and then you need to request it again. So at the moment, unless there are clients really struggling with nonce gaps, maybe we need to understand which is the impact of this one in terms of complexity and also increased bandwidth in case. So I will see the other more important to reduce the bandwidth than this one.
Thank you. Yeah, on the bandwidth, as I said, part of our bandwidth is simply, so there's the pushing of the transactions and then there is the announcement, and we are announcing basically to everyone. So that's lots of traffic there. We could easily reduce that without compromising robustness. If we think the added bytes are the problem, at least this is my opinion. That we can increase the size of the announcement and make less announcements because we are overdoing on that currently. And gap, when we also have gap management, it's more the issue of gaps when you are actually bandwidth limited.
Okay. Perfect. Any further questions, comments? I would want to time box this reasonably and reasonably soon move over to the next topic. But if there's like one more comment or question, we would have time for that. Okay, well then, thank you very much, Shaba. And there were some questions about whether you could share the slide link in chat. So in case that's shareable, then I think that would be much appreciated. Awesome. Then on to the next and last agenda point, which is the H-star Hegota headliner proposals. And just to clarify, because there were some questions around this, in the communication, I think it was on the Ethereum Foundation blog or something, there was this quote. The quote was basically proposals, headliner proposals for H-star must be submitted by February 4th. And must be presented at an Orconev's call. To clarify, the deadline specifically applies to the written submission of a headliner proposal, not to the presentation. So the idea is that as they are proposed, they can then be presented on the next ACDC or ACDE call, depending on where they are a bit of it. But you still have time until February 4th to propose them, and then that means that any EL side headliners that will be proposed until then can be presented, say, in 2 weeks on Orcodevs. That said, we have a few that are already proposed and are ready to be presented today. I think we have 3 on the agenda. And yes, I would want to start with the first one, which is the Universal Enshrined Encrypted Mempool proposal. And I think we have Yannick who wanted to briefly present this.
Yes, me, thank you. So yeah, the goal of EIP 8105 is to, as the name suggests, to add encrypted transactions to the protocol in order to prevent front-running and sandwiching attacks. Many users already protect themselves by using private RPCs and trusted builders, which I think proves that there's user demand. But the way this happens, we think, is problematic because it relies on trusted parties, which is bad for decentralization and censorship resistance. So we came up with EIP 8105 to fix this at the protocol level. We set ourselves some design constraints. In particular, we do not want to have any impact on regular transactions, which is typically a problem for encrypted mempool designs. We don't want to increase latency or have like liveness issues for regular transactions. And we want to have it neutral and future-proof. In particular, we don't want to favor any cryptographic mechanism. It should work, for example, with both threshold encryption or TEs or whatever other cryptographic solution people want to use. And the high-level overview over how it works is that we add a new role to the protocol called key providers. It's permissionless, anyone can register as one. And we add a new transaction type, encrypted transactions. And in this transaction, the user references one of the key providers that they trust. And then builders can include these encrypted transactions as normal. They only have to put them at the end of the block. So the block is split into two parts. First, the plaintext transactions, and then the encrypted transactions. And then once the block is published or the execution payload is published, and then the payload timeliness committee, then the key providers will release the decryption keys for those transactions that they see in the block. And then the payload timeliness committee that EPBS introduced will attest to which keys have been published and which ones have not been published. And once the attestation is there, transactions can be decrypted and executed. So that's basically it. We're proposing this as ideally as a co-headliner for Hequata next to Fossil, because we think this fits very well into a theme of improving credible neutrality and censorship resistance of Ethereum. Yep, that's it, I think.
Thank you. Do we have any specific concrete questions, comments on this directly?
I'm wondering like what key system this will use on mainnet.
So we would not prescribe any particular cryptographic scheme. Basically, when you register as a key provider, you also specify a decryption function in a smart contract, and this will then be used to first to verify decryption keys that they're the correct keys, and then to do the decryption.
I mean, are there quantum resistant key systems that would be performant enough for this?
I'm not an expert on this. I could imagine that for many schemes it would make sense to add particular EIPs to add these as a precompile. I'm not sure. Maybe some of them can be implemented in the EVM.
Good. Portos?
Yeah, I just want to comment that instead of like making it part of consensus for the same slot and pushing this on the PTC, that we're expecting it to be quite much later than what the PTC expect the payload to be available. This would force those transactions to only be executed at the very last bit of the slot, and this like loses all of the pipelining benefits that we have of this delayed execution. So I would suggest that you think about like forcing these transactions to be top of the next block. And the consensus over this is already enforced by PTC in the previous block. This doesn't change the ordering at all. And it allows you to actually have the full slot to execute them.
Yeah, it's interesting. And I'm not sure if it makes conceptually a difference at all. The only thing I think that's important is that the context under which the transactions are executed, for example, the timestamp or whatever, still has to be the previous block, so that the build of the next block cannot influence the execution path of the previous transactions. But yeah, the time in which they can, like, if they belong to the previous block or to the next block is, I think, kind of arbitrary.
And Lucas?
So the keys, which are not the part of the block body, will now be a historical thing that would need to be stored, for example, for archive nodes, ERA files, etc., right?
Yes, that's they're needed for execution. So and they're kind of, I don't know, like I'm not a client developer, and to me it seems like it's a bit of a split between the consensus layer and the execution layer. But in some sense, they have to be collected by the consensus layer and then passed on to the execution layer, so that and then executed as part of the block or become part of the block in some sense.
That's good. We would have time for one more question or comment. Anyone?
Wondering if there's any metadata of the transactions that are required to be in the clear. In previous examples of this, I feel like I've seen that like nonce or gas limit need to be available. Is that true for
Yes,
this?
so yeah, it's basically the same. The encrypted transaction consists of the encrypted payload, but also a plain text envelope, and that handles in particular, the fee payment for the encrypted transaction.
Okay, perfect. Thank you so much. I think there was a good kind of intro for people that didn't yet have context on this. And then of course everyone can go find the proposal and follow up there, and keep the discussion alive. For today, I would then move on to the second presentation so we can get through all three. So thank you, Yannick. And then next up will be frame transactions, proposed by Matt and Felix. Or I think those two wanted to give a presentation. So
Yes,
go ahead.
I can give the presentation. I mean, there isn't really too much to present per se. We didn't make the slides, but I can still, I mean, we can look at the EVE together, and I can quickly give an overview by just showing the parts of it. So this EIP is a proposal that is in the line of proposals for account abstraction, and specifically, it has, for us, is mostly about abstracting the transaction signature away to a system where the user account itself verifies the validity of the transaction, and more specifically, the account itself verifies whether the transaction was sent by itself. And there are other goals for account abstraction, and this transaction type also can do those, but for us, it's like the primary purpose is this like key management topic. There is a lot of there were a lot of previous EIPs related to account abstraction, one of them being the EIP 7701. This is in some ways an evolution of the EIP 7701, and also the ideas in this EIP 8141 were co-developed together with the team behind EIP 7701. So it's kind of like, this is basically like the combination of all the ideas that various teams had. So we feel like we feel pretty good about this proposal, because a lot of these ideas that were previously already tested in ERC 4337 and during the EIP 7701 development and so on. So there's like a lot of research behind it. That said, there's also some new stuff, and then one of the new things is this frame list. So basically, this transaction type basically adds a list of multiple calls to the transaction, and then the calls run at different permission levels. So we have 3 modes of execution, we call it here, but you can think of them as like both a permission level, but also basically configuring the EVM environment a bit differently for each mode. So we have one, this is like the unauthenticated mode, where the call happens from the entry point address. We have one we have a specific execution mode that executes like a static call, and this one is for the purpose of verifying the transaction signature, among other things. And then we have the sender mode, which basically executes as the actual transaction sender. So this is more like the authenticated mode that all the transactions execute in right now. So basically, if you think about current transactions, they have a single call frame that executes as the sender. And these other two things, there's no equivalent for them right now. And this adding the frames has some implications. So for example, also in the receipt, we have per frame receipts, which is useful, among other things, for native batching. So it's kind of has this like, basically it adds another layer of calls into the main loop of executing Ethereum. For right now, when you're executing a block, you will execute in a loop all the transactions within it. And in the future, you will actually even execute these transactions in parallel. So with this proposal, all of the frames of the transaction will also be executed sequentially. And the rule for executing it is specified all the way down here. And basically this rule is designed in such a way to make sure that before anything is executed as the sender of the transaction first has to confirm that the transaction is authentic, and in another step or in the same step, it has to confirm that the fees for the transaction were paid. And the fee payment is also decoupled from the sender, which is another goal of account abstraction, and it's also a goal that specifically for the smart accounts and the wallets to be able to sponsor the transactions of their users. So the users can pay for their own fees like they do now, but it is not required. And another entity can sponsor the fees of any transaction by adding, like, can another entity from the user can sponsor the transaction, but the user has to opt into using that entity also. So it's not like any transaction can be sponsored, but it requires cooperation between the user and the sponsor. Finally, we have some new opcodes that facilitate this. I don't want to go into the detail of it, but it's an area where I also suspect more changes will be made over time. They are not, the main one we have is the one that actually changes the semantics the most is the approve opcode, which is basically another way to return. So this is an opcode that terminates execution, and unlike return, it terminates it with a status code that is beyond the usual 0 and 1 status. So at the moment, returning from an EVM call has a success or failure state. And with this new opcode, there are 3 more states that a call can end in. And so this is like a change in EVM semantics. In the other opcodes are just environment access opcodes that do not have any impact on the macro operation of the EVM. And yeah, there's a lot more things to say about the EAP, but these are more like the detailed things. I just want to highlight that at the end of the EAP, we have a list of examples that kind of show the frame structure for common use cases that people have associated with account abstraction, and also use cases that are present today. So we have things such as a contract call in example 1, an ETH transfer, which has to be done as a contract call with this scheme as well, because there's no native value transfer facility. There is an account deployment, which is kind of an also critical step, because when people use smart accounts, they have to have code on chain before they can send transactions. So the scheme has to deal with that. And then finally, we have an example for the fee sponsoring. And here we also have some tables that basically aim to show that the overall size of these transactions, even though they operate in a completely different way from now, if you would use ECDSA signatures like now, the overall size of the transaction is only like 30 bytes more or something, or 20 something bytes more. So we feel pretty comfortable with this design, and we are happy to defend it. And we propose it as the headliner because we feel that it's a big change to the state transition. And it's also kind of, for us, the most important one because of the readiness for the post-quantum world. And I mean, we kind of feel like we have to get started with the off-ramp from ECDSA. And in order to do that, we need a comprehensive system that can deal with whatever signature algorithms we want to use. And so, yeah, this is our approach to doing that.
Sounds good. We will have a few minutes for questions, comments. Daniel?
Yeah. So my concerns about this are not so much technical, but we have seen with 7702 that the adoption for the smart wallets or for any changes in how we do transaction signing is very, very low. So I think I checked before in one of these dashboards, and we only have like 5,000 7702 transactions per day. I'm a bit worried that we would do this as a headliner, as a preparation for post quantum, but afterwards it's not really used. So I'm not sure if that's the best way to spend our resources, or maybe delay this and do other things first.
Yeah, there's not much I can say about these concerns. This is not since it's not a technical concern. For me, it's quite clear that like account abstraction has been one of these projects that has been ongoing for many years that people always wanted to realize, and we also see that the existing mechanisms that were proposed for in this direction, they are not adequate to capture what users really want to do. For example, even now with the EIP 7702, it is kind of a I mean, it is certainly a way to convert an existing account into an account with code, but it does not much more to help with the advanced use cases that people have. And also, it is not quantum secure. So in some ways, there is not too much. I mean, it helps you with some things, but it doesn't help you go all the way. And we kind of feel like some bigger change is needed to really help people realize the things that they have to do.
Yeah, I think it would just be maybe important, to talk with wallets and so, because one, I think, issues with 7702 is that that Ruby, for example, is not supporting it yet. So, to have some feedback, are they really willing to make to implement frame transactions or not? So this would be, I mean, I understand it's not a technical concern, but it's more what's the highest priority?
It is our plan to communicate with the users of with the builders of, for example, wallets and other infrastructure to ensure that they can find a good upgrade path. But ultimately, I think everyone has to face the question of upgrading their cryptography into something that is quantum secure, or at least something that is more practical for them. So we feel like we just have to provide the means first, and then we have to work with everyone to build out their infrastructure, because there's almost no incentive to build another infrastructure for keys when the protocol doesn't support it and doesn't look like it will ever support it.
Okay, thanks.
There was also a concern about the mempool, I guess, which I can answer. So Frangio asked the question, how does it look in the mempool? And for this, I want to highlight that this proposal has a section in the bottom that goes a bit into detail about this. We intend to expand this a lot more. The key thing to note is that while the inside of a block, an arbitrary interaction can take place. For example, you could have transactions that do not contain a signature verifying frame. In some cases, this can actually be fine, but for the purposes of the mempool, we will validate the transaction to conform to a specific known frame structure, and this includes having a gas limit on the signature verification and ensuring that there's only a single verifying frame, and ensuring that this verifying frame does in fact cover the fees of the transaction, as well as basically having a valid signature. So in the public mempool, these transactions will be much more limited than their feature set might allow. However, we see it as an advantage that for a specific application, custom mempools can be built that validate the transaction according to more specific rules. Whereas if you just want to make a general verification of transactions, you have to really limit what the transaction can do inside of its verification phase. But once these limits are applied, one key thing to realize is that using the EVM to verify the signature isn't different from calling the ECDSA verification in the native code. It's just a different way. It's just a different signature algorithm in the end. But this, you can see it this way if the environment that verifies the signature is sufficiently limited. And we do intend to place these limits in order to make this compatible with the mempool. But it's also an explicit design goal for this proposal to be compatible with the public mempool as much as possible.
Yeah, just to time box, I think Vitalik, you were unmuted, so if you have one more comment, and then
Yeah.
afterwards we have to move on.
Yeah, I think I also just wanted to add that, like, from a use cases perspective, this does like basically satisfy everything that's at least I've been pushing for, like the entire list of goals of account abstraction, including like the original ones and including various things that have been bolted onto the topic over the years. And I think it's particularly nice how like this design has very few special purpose features from these things. They just fall out naturally from the ability to have multiple a verification frame and execution frames. So it satisfies the natural stuff like different signature algorithms, including passkey friendliness. Now that we also have the SIG P256 R1 precompile, it satisfies post-quantum SIGs. It satisfies native multisig. It also, I think, also worth highlighting, there's this nice synergy with Fossil, where privacy protocols and also even transactions paid with paymasters can be sent through it. And there's a path to make that Fossil compatible without intermediaries. And so there's a benefit in terms of censorship resistance for privacy. So I think, like the post quantum aspect is definitely the aspect of like, it's the reason why account abstraction of some form is ultimately indispensable. But like the generality of this thing is also very powerful for a whole set of other goals from like basically every camp of the account abstraction community as well.
Sounds good. Then I think we really need to move on now to the last headliner proposal. I'm sorry that we ended up running over a bit. Ethan wanted to talk about SSE execution blocks. Ethan, you only have a few minutes. Of course, you can go a little bit over, but some people might have to drop off. If you feel comfortable with that time, we could, of course, also push by 2 weeks, but feel free to go ahead now if you're comfortable with that time.
No, it's okay. It's okay. I can make it really quick. Essentially, like, can you see my screen?
Yes.
Okay. So this is just like a follow-up on the Purith that was discussed for the headliner for Glamsterdam. Back then it was way too big. Like, this was like the scope. But what happened is like that the individual pieces got proposed independently. And now we got like the ETH transfer logs on the EL and the progressive SSC types on the CL as like a partial scope. And at the same time, we also have this breakout call from Scholt every second Tuesday about the log index and so on. The goal is still the same, to be able to build a wallet without relying on trusted third parties. So now the idea is to reduce the scope, essentially focusing on what's urgent right now. Like, it's mostly the engine API that needs rethink, because we are starting to get latency issues there because of the data format conversion, like converting from SSC to JSON to RLP, especially at higher blob counts. And also like we have the problem with the hashes for the transactions and receipts. As a reminder, these are linear hashes today. And transaction data includes call data, and the receipt contains the log data, and it's all just a single linear hash. That's a problem for payload chunking if we want to move the payload into the blobs, for example. So getting this in here just fits naturally. So the question now is, how big do we want to make it? So the bare minimum would be like just the binary engine API, the transactions try, the receipts try, and the SSC block hash for the block payload. That would allow like the EL to pretend that is full SSC to the CL. The CL could just get all these benefits, but also at the same time, we have these new transaction types, both of these proposals, and I think it makes sense to just combine it in a way so that whatever we add now, like if it's the framed transactions or the encrypted transactions, just builds on top of SSC so that we get these binary trees so that we can fetch partial transaction data so that we have on-chain commitments to the contract address, to the sender address, and so on. So yeah, that's the idea. Like, how big do we want to make it? Right now, I propose it as a headliner, just because of the synergy with the new transaction type. Yeah, if it doesn't, like, if we want to stay with RLP MPTs and like convert to avoid database networking revamps, then we can also reduce it again for this fork.
Sounds good. Thank you very much. Of course, some people might have to drop off now, but if there's like one or two questions, we could run over a bit.
I'm all for binary engine API and binary EL RPC. Yeah. Definitely needs to be oh no, that's for the previous one. Yeah, I mean, we have synergies with the transaction EIPs, so like the only thing is if we want to do it, then we should probably start to put those transaction EIPs on top of SSC rather than RLP. Should be a rather small change.
Sounds good. Any more questions or comments? Okay, well then we just managed to finish the scope of the call. Perfect. Thank you all very much, and I'll talk to you all in 2 weeks. Bye, everyone.
Bye-bye.